You've seen the movies, right? A giant rock hurtling through space on a collision course with Earth. But is that just a Hollywood plot, or is it a real threat we should actually be preparing for? Well, let's dive in, because for the first time in 4.5 billion years, our planet finally has a defense plan.
And yet, this might look like something out of a sci-fi flick, but the threat is very, very real. And you know what? We don't even have to look back millions of years for proof. A pretty stark reminder from just the last decade showed all of us that the sky can and sometimes does fall. That wake-up call came on a totally normal February morning back in 2013 over the Russian city of Chelyabinsk. And this one event completely shifted the conversation about planetary defense from something theoretical to something very, very urgent. No, this is not a special effect. This is the actual smoke trail left by a 20-meter asteroid as it tore through the atmosphere. It exploded with the force of, get this, roughly 30 Hiroshima bombs, creating a flash that was literally brighter than the sun. So what does that kind of power do to a city below? Well, this was the human cost. Over 1,600 people were injured. And the craziest part, the rock never even hit the ground. This was all from the massive shockwave that rippled out, shattering windows and damaging buildings all over the city. So the big question, the really crucial question is, how did we miss it? How did a 20-meter rock sneak up on us? Well, it came from our biggest blind spot, the blinding glare of the sun. The Chelyabinsk event was proof that even small asteroids can cause a ton of harm, and that our ability to spot them is far from perfect. You can imagine, that event really lit a fire under the scientific community. It made it clear that this isn't about just one surprise rock. It's about systematically finding and tracking all the objects out there that could pose a danger. Which kind of begs the question, what exactly makes an asteroid dangerous? Well, scientists have a very specific definition for this. It's called a potentially hazardous asteroid, or PHA for short. And for an asteroid to get that scary-sounding label, it has to meet two criteria. First, size. It's got to be bigger than 140 meters, which is big enough to wipe out a city. And second, proximity. Its orbit has to bring it uncomfortably close to ours. This chart does a fantastic job of breaking down the risk. So a 25-meter rock, like the one over Chelyabinsk, that kind of thing probably hits us about once a century. But as you can see, when you move up to a 140-meter city killer, the impact becomes absolutely catastrophic. And then you have the 1-kilometer civilization enders, well, the name says it all. And this right here, this visual really lays out the challenge we're up against. When it comes to those city killers, the ones 140 meters or bigger, we've only found about 39% of them. That means the majority, more than 60%, are still out there, orbiting in the dark, completely unknown to us. Of course, this isn't a new problem for our planet, not by a long shot. Earth's entire 4.5 billion year history is basically written in impact craters. We are living on a cosmic dartboard, and the geological record is filled with evidence of past strikes, some of which changed the course of life itself. This timeline really gives you a sense of the different scales we're talking about. You go back 66 million years, a giant 10-kilometer-wide asteroid comes in and ends the age of the dinosaurs. Then, 50,000 years ago, a much smaller, 50-meter rock leaves a massive scar in what is now Arizona. And just over a century ago, the Tunguska event in Siberia showed what an airburst from a similar-sized object can do. It flattened a forest the size of a major city without even hitting the ground. And this is that scar in Arizona. It's called the Barringer Crater. It's over a kilometer wide, and it was created by an object just 50 meters across. I mean, just imagine this happening today in a populated area. This is exactly what keeps planetary defense scientists up at night. But here's where the story takes this incredible, optimistic turn. Because after billions of years of being a passive target, life on Earth, well, specifically us, has finally developed the ability to fight back. We are the first species in our planet's history that can actually do something about this. So how do you actually stop an asteroid? We have several really compelling options. The most direct approach is called a kinetic impactor, which is basically a fancy way of saying we hit it with a high-speed spacecraft. For bigger threats, or if we're short on time, there is the nuclear option. And for more delicate, long-term nudges, we could use a gravity tractor or even high-powered lasers. I love this quote because it just perfectly captures how significant this moment is. The dinosaurs were wiped out by a random cosmic event they couldn't possibly see coming or do anything about. We have the knowledge and the tools to change our own fate. And, this isn't just theory anymore. We've actually tested it. This is NASA's DART mission. That stands for Double Asteroid Redirection Test. The plan was as simple as it was audacious. Fly a spacecraft millions of miles through space and deliberately crash it into a small asteroid just to see if we could change its path. And the result? It worked. In September 2022, for the very first time, humanity successfully and intentionally altered the motion of a celestial body. It was an absolutely monumental achievement for planetary defense. And I mean, it didn't just work a little bit. It worked spectacularly. The team was hoping to shorten the asteroid's nearly 12-hour orbit by just over a minute. The impact actually shortened it by a full 32 minutes. We gave that rock a much bigger push than anyone expected. We now know for a fact that we can move an asteroid. The success of DART is amazing, but it really marks the beginning, not the end of this story. So with this proven capability in our back pocket, what comes next in our mission to guard the future of our planet? Well, the next critical step is finding all the threats. Missions like NASA's NEO-Surveyor and the European Space Agency's NEOMIR are being designed specifically to hunt for those hidden asteroids, especially the ones coming from the direction of the sun, just like Chelyabinsk did. And at the same time, international agencies are running drills and developing the plans we'll need to respond to a real threat, so we're ready when, not if, the time comes. This really shows the potential evolution of our relationship with these space rocks. On the left, that's where we are now, with DART, our first successful defense. But on the right, that's a vision of the future, one where we've moved beyond just defense, and asteroids are no longer just threats, but potential resources for humanity's expansion into the solar system.
Which brings us to this final thought. We live in an absolutely unique moment in history. We are the first generation of humans, and the first form of life on Earth, ever, that has the power to prevent a major extinction-level event. The technology is here, so the question isn't no longer, can we do it? The real question is, will we?